Hello everyone, welcome back to session 6 of Statistics for Data Scientists. And this is the part third of Inferential Statistics. And today we are going to start with the t-test. In our previous session, we have started with hypothesis testing and we covered and we started the z-test. We have seen an implementation of z-test and how we can calculate the statistics using the z-test under what conditions, what circumstances, what would be the sample size. Okay, so basically there are different situations when z-test should have to be implemented. Okay, now see, a t-test is a statistical hypothesis. It is also a statistical hypothesis test which is used to determine whether there is a significant difference between the means of two groups or population. Okay, it could be a group or population. Okay, we will see that when we have one sample t-test and two sample t-tests. In that case, we will see. Okay, now there are certain conditions where this when this t-test should have to be implemented. The point number one is that it is used when the sample size is less. In z-test, what was the condition? When the sample size was greater than 30. But in t-test, we will implement when the sample size is less than 30. In that case, we will implement the t-test. The point number two, population standard deviation is not known. Okay, and these are the two conditions. In that case, we can implement the t-test. In z-test, the condition was that the sample size was greater than 30 and standard deviation should be known. Okay, but in t-test, these two conditions are opposite. The sample size is less than 30 and standard deviation is not unknown. Okay, now basically okay, assumption of teachers, the populations from which the samples are drawn are approximately normally distributed. So basically this is the normal conditions for almost all the tests, that the population from the samples which we are picking up from the population, it should be a normally distributed data. Okay, all that within all the tests, whether it is z test, t test, f test, and over test, the samples that we are considering, it is being considered from a normally distributed data. It should not be skewed. Okay, and the samples are independent for an independent sample t test. The difference between the paired observations are normally distributed. Okay, so these are not uh, I'm sorry. Now see, so we have two types of t-test, one sample t-test and two sample t-test. Now, that's the one sample t-test is that when we have to compare the sample mean within that of a population mean. Okay, when we are comparing the mean of a sample with the population with its population mean, in that case we can use one sample t-test. But when we have to compare the means of two different samples itself, in that case we can use two sample t-test. Okay, now the one sample t-test is almost similar to as that of set test. Okay, here the x bar is nothing but the sample mean, I'm sorry, and mu is the population mean. S is the standard deviation and n is the sample size. In this case, in case of x1 and x2, these are the sample mean of two different groups, sample groups. This is the population mean of two different population group, and accordingly the sample size and yeah, n1 is the sample size. So okay, okay. Let us take an example of t-test now. Okay, in the first example, you can see that a random sample of size 20 from normal population gives a sample mean of 42 and the sample standard deviation of 6. Test the hypothesis that the population mean is 44, right? So, okay. No, so what about the, like, let's see what are the details we have. So we have the sample size given as 20, right? And then we have the standard deviation given as 6. Okay, and the sample mean, we have the sample mean given as 42. Okay, population mean we have given 44. Size is 20 here. Okay, it is less than 30. So Okay, so thus the step one towards the hypothesis testing is the formulation of hypothesis. So basically in t-test, okay, so what are we going to consider is just a moment. So in this case, so the H naught value, okay, the it is going to be 44. Okay, the mean of population mean, that is the population mean, right? And the step two, in step two, see, so the for and the alternative hypothesis. Okay, so in that case, the H1, the yeah, the H1 value will be, it will not be equal to 44. Now you know that basically in one tail test or two tail test. Okay, if I have to delete this, just a moment. So we can have mu greater than um, v naught. Okay, and then we can have mu less than mu naught, and we can have mu not equal to mu naught. These are the three different conditions for one tail, two tail, and left tail, right tail, and two tail. Right. So this is the left tail. Right. This is the case of left tail test, and this is the case of right tail test. Right tail test, and this is two test tail. Two test tail. The question over The question over here is that which is which alternative, like which tail test is applicable in this case. Now the important point over here is that from the question itself we have to identify whether it is a right tail, left tail, or it is a two tail test. So mainly we have to find whether it is a one tail test or a two tail test. So the very easy way to identify whether it is a one tail test or two tail test. So when we have greater than, less than, or it is when it represents in particular direction, less than, greater than, above. Okay. So if you will find these kind of keywords, then you can identify that whether it is a one tail or two tail. If these keywords are not given, okay, then in that case it is going to be a two tail test. If you will find it is greater than, less than, okay, this kind of words, in that case it will be a one tail test, right? So this is basically the way to identify. We have to identify the direction actually. Okay. So in step one we have formulated the hypothesis, null hypothesis. In step two we have uh, we just uh, had formulated the alternative hypothesis. Step 3. Okay. Now in step 3, in this case, we have to the significance level. We have to identify this. We have to select the significance level. Now, see, basically, when we don't have any level of significance given in the question, so the standard significance level we used to consider it as 0.05 for confidence interval of 95%. Now in step 4, we have to calculate the test statistics. Okay, test statistics. Okay, H naught. Okay, so basically now the question now. So we have two different t calculated value. Okay, one is for the sample t calculated, and the sample mean minus the population mean by sample size by n. Okay, or t calculated is x mean mu by s by the full degree of freedom will be n minus 1. The question over here is that which one is to select, which one we have to select. Okay, whether to select sample t calculated or the population t calculated value. Now see, when we have the standard deviation given in the question itself, Okay, now in our question we have the standard deviation given. So in that case, we will select the like, we will select n minus one. Okay, so in that case, if we have find the t calculated value, so it will be x mean. So what is the mean value we have? I. Okay, so 42, 42 minus 44, and then we have standard deviation 6 by 20 minus 1 19. Right, minus 2 by 6, 19. And I already calculated it, so we are getting 1 point minus 1.45. So if we will take the mean absolute value, okay, if we will take the absolute value of t calculated, okay, it will be 1.45. Right. Now step 5. Right. Step 5. Okay. So in step 5 we have to uh, in- uh, so basically we have to take a decision now. In step 5 we have to take a decision. Okay. Step 5 we have to take a decision. We have to. So basically now the t calculated and we have t tabulated. Okay. So t calculated is 1.45 and t tabulated is okay. Okay, I think I just missed one step. One. Okay. Okay. Now see. So this is the t calculated value, and now for significance level 0.05. Okay, for significance level for level of significance 0.05, the t tabulated value if we'll check it in the table, we will be getting a 0.2.093. Okay, this is the t tabulated value. Okay, just you can follow it from the table. Okay, now the step 5. Step 5 is making a decision. Okay, decision. So we have this t calculated value and we have t tabulated value. Right. So T calculated value, our value is 1.45, right? 1.45 and T tabulated value is 2.093. Okay. And you can see that tabulated value is greater than, uh, okay, it is greater than T calculated. Now, when the T calculated value is greater than, tabulated value is greater than zero, is greater than the calculated value, so it does not provide us a very significant difference. Okay, in that case, we have to accept the null hypothesis, and we do not reject the we reject the alternative hypothesis. So so it is not significant. Okay, it is not significant. It is not significant, and we do not have enough evidence. We do not have enough evidence to reject null hypothesis. Null hypothesis. So we reject the alternative hypothesis. That is all about the decision that we are making over here. Okay. So what we did exactly here, okay, we have all the values given, okay, the sample size, standard deviation, the sample mean, and the population mean. Okay, so in the step one, we just like like so we just consider the mu value, okay, that is the population mean value, okay, which is similar to the Z test, whatever we did in the Z test. And then in step two, okay, we just identified which whether it is a one tail test or a two tail test. We found that it is a two tail test. Okay, so in that case, the H1 value will be okay here. Okay, so the H1 value will be so it is not going to be the population mean is not going to be equal, right? Now if we have to identify the significance level, if it is given in the question, it's okay. Okay, in case if it is not given, we will take the standard deviation of 2 and confidence interval 0 like 95%, so the significance level will be 0.05. In step 4 we have to find the test statistic. So the t calculated or t tabulated, we have two different formula available. So now we have to identify it from the question itself. When we have the standard deviation given in the question, if it is given, yes, in our case it is given as 6. So when it is given, we have to follow this n minus 1, right? The degree of freedom will become 19 in this case, and so the t calculated value is 1.45. Okay, now for the level of significance 0.05, the t tabulated value is 2.093. Now in step 5, we have to take a decision based on t calculated and t tabulated value. Since the t tabulated value is greater than calculated value, so it is not a very, there is no significance. Okay, and we have not enough evidence to reach the null hypothesis. So we have to reject the alternative hypothesis. So that is all about the t-test. In the next session, we will talk about the f-test, okay, or the ANOVA test. Okay, so I will see you in the next session. Thank you.